So here I am with Ettore Tiotto,
Hey, how are you doing?
who is a senior developer here at IBM in Markham. And Ettore is one of the people that work in the original project that led to Gazprea, the language specification that we use now in 4.15. So Ettore, tell us a little bit about Gazprea, which was called Dash at the time.
Yeah, at the time we changed the name a few times. So the idea was to create a new type of programming language, a more high-level programming language that you would be able to use it to exploit, parallelism in new type of accelerator, whether they are FPGAs or GPUs. And where the programmer doesn't have to go down to the low-level machine details or use low-level languages like C++ or even Java and try to express the parallelism at a much higher level. So we had that was the main idea. The motivation for us to do this project in IBM was that we were working on trying to solve a complex graph containing financial calculations, and so the original program was written, as I recall, using C++.
Yeah.
And the issue was they were trying to model the market, to model security, to model risk, to do risk analysis, and this was part of IBM algorithmics. The quantitative analysis of the quants would come up with a new mathematical model, and then typically write that model using high-level language such as MATLAB. Then when they went to run it and prototype it, the model would run too slow. It wouldn't even run it in parallel. So that code would then be given to professional C++ programmer that knew nothing about the math, and they had to spend some weeks or months to actually tune it, rewrite it in all-level languages. And there was a iterative cycle, because the model would then be refined, the mathematician would have a different idea, and they could not take the C++ code directly and modify it because they are not programmers. They would modify again the model, and the cycle would continue. So we were the idea was to try to create a language where either a quant or anybody else that has an interesting idea, mathematical idea, would be able to use it, such as using something like more like Python or a sequence of nodes that do like a map and then a reduce, a scan operation. So we had things like generator and so on.
Yeah, and we have all this in the Gazprea language now.
Yeah.
So historically this interesting happened because you guys had the Extreme Blue project based on that language, and then eventually there was no business case made for IBM to continue that project. And pretty much what we have tangible today from all that work is the language specification that Compute 4.15 uses, and that the students are going to be now using to produce this compiler. So just another thing, the compiler will be targeting LLVM. So how about if you tell then a little bit about the importance of LLVM in current business that you guys are doing?
Yeah, so at the time we actually had a compiler that was actually able to either target LLVM IR or just generating C code and then translate C code down to machine level, and we could do both interchangeably. Now, there was, I believe it was at least 4 years ago. So in that time, the adoption of open source tools based on LLVM IR has grown exponentially within the industry. And pretty much every company or most of the compiler vendors are migrating their own internal infrastructure more to the open source, which is a good thing because we can involve the academia more, we can foster collaboration. It's also much easier to collaborate with other people because we are all using this set of wonderful tools that are part of the LLVM project. So I think in general LLVM is the way to go, is the future, and I see a lot more of the proprietary technology of IBM or any other companies moving more toward the open source. IBM has had a great history and tradition of sharing, and in fact, like the fact that we actually gave the specification of the language, it's a testament to the willingness of this company, of IBM, to collaborate and be open and then try to engage academia in doing interesting research. So I'm personally very happy that you were able to
Yeah.
to run with the project and use
Yeah.
it to teach to students what it's like to build a language from the ground up.
Exactly. So this is really a building from the ground up experience. And so one more thing, we have had a very long relationship with IBM,
Very
University of-
good and very productive relationship.
and we have had lots of students come here.
Yeah, absolutely.
And so that's another thing that I'm here today to visit for a research visit.
Yeah.
But a number of the students that go through this training in the courses, they end up with an experience in this building and developing
And
interesting things.
it's been going on for over a decade, and it's going to continue to go on, as far as
Yeah.
I'm concerned, for us as long as we can, as long as we actually have interest in the idea and into its work. It's been extremely beneficial for us because we get to use new talent, and we get to obviously find good people and then potentially hire those
Yeah.
people. We have a long tradition of fostering collaboration with the academia. The CAS project, like the CAS program, is probably one of the best in Canada,
Certainly it
if
is.
not even Canada and the US, where we, basically we help talented students and professors to do the research using tools. And this research is not just pure research; it's more research toward concrete goals. So currently I'm working with in the Coral project, and some of the work that the University of Alberta has done in the past couple of years in collaboration with IBM has been then used as technology in a product that we actually ship to the customer, and they're being used by them as part of the Coral project today. And the good news is that not all the things that we have worked on, or all the idea that we have discovered collaboratively, are actually yet implemented in the production compiler. So we have a pipeline on new idea, and collaborating with research, and in particular with people like you, help us to build that pipeline and keep it alive, keep the innovation going. And
Just this morning, we're delivering some news to Ettore about some of the new work that we are doing with undergrad students that have just taken Compute 229 this past fall at the U of A. So we're going to keep working, keep doing that. So thank you very much
You're
for your
welcome.
time, and nice to be here with you.
thank you.